There is no specific code limit on the number of switched outlets that can be connected to a single switch or circuit. However, there are several practical limitations that must be considered to ensure safety and proper operation. These limitations primarily revolve around circuit breaker or fuse protection, wire size, and voltage drop. Firstly, the circuit breaker or fuse protecting the circuit must be appropriately sized to handle the total load of all the outlets connected to it. The circuit breaker's function is to protect the wiring from overheating, which could lead to a fire. If the total current drawn by all devices plugged into the outlets exceeds the breaker's rating, the breaker will trip, interrupting the circuit. To determine the appropriate breaker size, you need to calculate the total load in amps that the outlets are likely to draw. For general-purpose circuits, the National Electrical Code, or NEC, typically requires you to calculate the load at 180 volt amps per outlet. This doesn't mean each outlet will necessarily draw 180 volt amps, but it provides a standardized method for estimating the total load. For example, if you have a 15 amp circuit at 120 volts, the maximum allowable load is 15 amps times 120 volts, which equals 1800 volt amps. Dividing this by 180 volt amps per outlet gives you a maximum of 10 outlets. Similarly, for a 20 amp circuit at 120 volts, the maximum allowable load is 20 amps times 120 volts, which equals 2400 volt amps. Dividing this by 180 volt amps per outlet gives you a maximum of approximately 13 outlets. It's important to note that these are general guidelines and specific applications may require different calculations. For example, if you know that the outlets will only be used for low-power devices, such as lamps, you might be able to exceed these limits. However, it's always better to err on the side of caution and avoid overloading the circuit. Also, consider the potential for future use. Even if the outlets are currently used for low-power devices, there is a possibility that they may be used for higher power devices in the future. Therefore, it's generally a good idea to limit the number of outlets on the circuit to a safe and manageable number. Secondly, the wire used to connect the outlets must be large enough to handle the current draw of all the connected devices. The size of the wire is measured in American wire gauge, or AWG. The smaller the AWG number, the larger the wire. Larger wires have a lower resistance, which means they can carry more current without overheating. The NEC specifies the minimum wire size for different circuit ampacities. For example, a 15 amp circuit typically requires at least 14 AWG copper wire, while a 20 amp circuit typically requires at least 12 AWG copper wire. Aluminum wire is also permitted, but it has a lower ampacity than copper wire of the same gauge. Therefore, if you are using aluminum wire, you will need to use a larger gauge wire to carry the same amount of current. The NEC has tables that specify the ampacity of different types of wires based on their gauge, insulation type, and installation method. It's important to consult these tables to ensure that you are using the correct wire size for your application. Using a wire that is too small can cause it to overheat, which can lead to a fire. Furthermore, using a wire that is too small can also cause excessive voltage drop, which can affect the performance of the devices connected to the outlets. Thirdly, excessive voltage drop can occur if the wire is too small or if there are too many outlets in the circuit. Voltage drop is the decrease in voltage that occurs along a wire due to its resistance. When current flows through a wire, some of the voltage is lost due to the wire's resistance. The longer the wire and the smaller the wire gauge, the greater the voltage drop. Excessive voltage drop can cause a variety of problems, including dim lights, slow-running appliances, and malfunctioning electronic equipment. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, you need to know the length of the wire, the current flowing through the wire, and the wire's resistance. There are several online voltage drop calculators that can help you with this calculation. You can also use the following formula: voltage drop equals 2 times K times I times D divided by Cm, where K is the direct current resistance factor for the conductor material, I is the current in amps, D is the one-way distance in feet, and Cm is the circular mils of the conductor. The value of K is typically 12.9 ohms for copper and 21.2 ohms for aluminum. The circular mils of a conductor can be found in the NEC. To minimize voltage drop, you can use a larger gauge wire, shorten the length of the wire, or reduce the current flowing through the wire. As a general guideline, it is recommended to limit the number of switched outlets on a single circuit to 10 to 12. This will help ensure that the circuit is not overloaded and that voltage drop is minimized. However, the actual number of outlets that can be safely connected to a circuit will depend on the specific application and the factors discussed above. It's important to consider all of these factors carefully before adding outlets to a circuit. Ignoring these practical limitations can create unsafe situations such as overloading the circuit, which can cause the circuit breaker to trip frequently, or worse, it can cause the wires to overheat and start a fire. Undersized wires can lead to voltage drop, causing appliances to function inefficiently or not at all. Therefore, a careful evaluation of the load, wire size, and circuit breaker rating is essential for ensuring a safe and functional electrical system. In residential wiring, understanding these considerations is crucial. For instance, in a living room, you might have several outlets for lamps, televisions, and other electronic devices. It's important to estimate the total power consumption of these devices to ensure that the circuit can handle the load. If you plan to use high-power devices such as space heaters or power tools, it's even more critical to dedicate a separate circuit for these devices to avoid overloading the existing circuits. In kitchens, where multiple appliances such as refrigerators, microwaves, and toasters are commonly used, it's often necessary to have multiple circuits to distribute the load. The NEC has specific requirements for kitchen circuits, including the number and type of circuits required for countertop outlets. When planning electrical work, it's always a good idea to consult with a qualified electrician. An electrician can help you assess your electrical needs, determine the appropriate wire sizes and circuit breaker ratings, and ensure that your electrical work is done safely and in compliance with the NEC and local codes. Working with electricity can be dangerous, and it's important to take all necessary precautions to avoid electric shock or fire. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, it's best to leave the work to a professional. Furthermore, consider the type of devices that will be plugged into the outlets. Some devices, such as LED lighting, draw very little current, while others, such as power tools or appliances with heating elements, can draw a significant amount of current. It's important to consider the type of devices that will be used when calculating the total load on the circuit. Also, keep in mind that the load on a circuit can vary depending on the time of day and the activities that are taking place. For example, a living room circuit might draw more current in the evening when people are watching television and using lamps than during the day when no one is home. Remember that the NEC is updated periodically to reflect changes in technology and safety standards. It's important to stay up to date on the latest code requirements to ensure that your electrical work is in compliance. The NEC is available for purchase from various sources, and many local libraries also have copies available for reference. Additionally, many online resources provide information about the NEC and electrical safety. It's also worth noting that local jurisdictions may have their own electrical codes that are more stringent than the NEC. It's important to check with your local building department to determine the specific code requirements in your area. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before undertaking any electrical work. Electrical work can be dangerous, and it's important to take all necessary precautions to ensure your safety and the safety of others.